Hello everyone, today I'll be servicing NAD 3020. You might ask why second time the same model? Well, even though it has the same name, isn't the same inside. So in a moment you can see what's different. But first let's check if this is an original NAD 3020. There's only one way to check if it's original or not. 100% original. Okay, so I'll be looking for the button now and let's get started. The front panel is in quite nice shape, and from the feel of the potentiometers I feel a little bit of resistance and suspect that it was not cleaned. Holding the volume potentiometer is a little bit loose, but it's normal for this model, it's an easy fix. Let's take the cover off and let's take a look inside. To take the top cover, only 3 screws on each side. Okay. Okay, let's see. Quite a nice view, not very dusty. Let's take a closer look. The original Motorola transistors. All caps looks original. Just one thing I noticed that's a little bit concerning, and it's this. This what worries me a bit. This isn't even an electrical tape, this is just a painter's tape. I don't know the condition of this amplifier. Sometimes people cut the power cord to show, to warn not to connect to the mains. Somebody maybe thought, oh, I will try, and then, you know, bad things can happen. Let's check out what's here. Sometimes you can find surprising things under such tapes. Huh. Here the connection, I think it's fine. The colors matches, that's fine, but here somebody didn't know how to remove the outer layer. Basically you can see bare wires, which is not so good. A quick closer look here. So somebody cut it not very carefully. This side's better, this side's not so good. Anyway, I will just add some electrical tape for my safety. And what it does, basically, if it works or not. I will remove this cord anyways. I'll just quickly confirm the continuity here. This is fine. This is fine. Fine. Let's see if we have any shorts here. No shorts. I think you've noticed it's lighted just a little bit. I also noticed you didn't notice I saw the VO meters, the power switch probably, or the caps. With the speakers I would have a bump. Let me check DC offset here. That's what's interesting for me. So here I have 30 millivolts. And here I have minus 50, so it's relatively safe for the speakers. I don't see anything suspicious, but I will keep this. Still, I will turn it off, do some measurements underneath. But before that I will take off the front, because I don't want to, you know, the front is plastic and it's quite fragile. When I turn it on many times I don't want to damage it. It's quite easy to take it off. I just have to take those knobs if I can. Oy, this one is a little bit sitting here quite strong, but I'm strong. Okay, that's on. Okay, there are two screws here and here. Let's take the first one out. Okay, anyway, nice to see the plastic here is not broken. Second screws here. I have also two screws here that are mounted to the front panel, this little board with diodes of the VO meter. Okay, and the second one. Will I be able? Yes. Good job. And two screws at the bottom. They still have the factory seal paint on them, so I know the front panel wasn't removed. Okay, that should be enough. Let's remove a little bit of it so that I can coat the screws without any effort. So another good news, I don't see this was ever removed, and the bottom cover is very nice shape, very beautiful. Goes off quite easily. They're long. Okay, this is what I'm talking about. I will move this around many times. Two more quick things before I remove the front panel. This is one of them, and the second one, we'll try to be gentle with this board. Yeah, and now I can remove the front panel. Right, let's take it out. Slowly, patiently. Okay, and now I can put it somewhere safe, and after, of course, I will wash it. It's a little bit dusty. You spot if this is the later 150 watt version. It's quite easy. You see the main filtering caps. In the previous version they are here. You don't see the phono power board. In the first version there is a special board here, and this guy is mounted fully on the back. Of course, here you see 150 watt. You don't see the holding holes of the phono board that's mounted here. So those are the differences. To be honest, I think NAD should market it somehow that this is a revision. This amplifier sounds differently than the first version, really. Anyways, you can see the earlier NAD 3020 in my previous video, link in the description and on screen. Yeah, let's move it on the other side. This guy here, and I will remove this cover and we'll check out what's there. One thing to notice, those two screws are shorter, and it's quite important that you don't mess them up later, because if you put longer screws here, that you can have some trouble if they touch the board. Okay, 6 more to go. Yeah, see, this one is longer. And done. Let's see what we have here. Okay, I will take out this mounting panel. I would use a normal screwdriver here, front. This one is a short one. And also short, capped by screws from this side. I will leave it here. Okay. Sometimes washer are here, so I'm not sure if somebody took it off and didn't put it back, or I don't know. I will never know now. Yeah, definitely somebody was working here. Definitely someone was here before me. This is one of the spots that I suspect someone was here. I really doubt this is like this. This came out of factory like this. If you can see, this soldering has a lot less solder than here, and it's much cleaner. The residue it's a lot of things. This is also a little bit suspicious. This is, I think this is not cut, it's just old glue here. Yeah, nothing to worry too much. Another spot is here, here, here. So many points like this. Definitely someone was working on it, but didn't exchange anything, just probably corrected some joints, and that's it, and didn't clean. Maybe sometimes it's good that people don't clean, so then the next one who is working can more easily spot what was done. I will power it up still under the protection. Protection works really nice. And I will just measure the main filtering. Yeah, this is a little bit lower, of course, should be, but no problems here. No problems here. Measure the offset once more. It will rise. Okay, this is still acceptable. I think this is the rectifier. Yep. Yeah, this is this one. Yeah, see, when I will run it without the protection, with protection it's 33. Without protection it will be 35 something, and those caps are rated for 35, so they really need to be 50 at least. Anyway, I don't see much problems here. Might ask why I'm testing it instead of just servicing, change the old caps and so on, change the thermal paste under the transistors, and you know, I just want to know the condition before I start any work. If there is any problem, I want to figure out and deal with the problem before I start recapping this piece. So it's time to resign from the protection, no problems. Now it's without the protection, and we'll see how the voltages looks. Yeah, that's healthy. That's good. That's also fine. Fine, let's check here. This was this one. See, 35, so it's above the range of the original cap. 35.6. It's basically by the book. This is 220 volts, and I run it through a variac. Here, how much is it? 75 millivolts of the ripple. You will compare it, we will compare it with new caps. Here. Whoa, 406. This is a lot. Really? This is very, very, very bad. Oh, okay, it was a measuring mistake. The back is just to prevent any shortage here. Just want to show you what happens when I turn on the amp. Now I will turn it on. See, so that should not happen basically, and if the speakers are connected, it will be stress for the speakers and a really unpleasant noise. Fortunately, there is a way to check where is it happening. I will just take those out. Come on. And I will turn it on again. So this is a preamp thing. So before starting service, I will try to find the issue of this. Those three caps are here, and I believe here. Let's check the first one. This is C331. No. Yeah, minus 56 point something. It should be minus 62. And here 20. This is rated 63 volts, so it's already above the voltage rating. So this cap is really, it came out of the factory, and the cap voltage isn't right. And here minus 56.4. This should be 0, yes. Also this cap is rated for 50 volts, and I have to keep in mind I'm running it variac, so the voltage is spot on, and in spot on voltage this cap should be rated at least 63 volts, and it's 50. So it came out of factory, and the voltage isn't right, so those two caps are really prone to fail. Anyways, here should be at least 100 and here at least 63. I will exchange them and see if it happens with the bump at the beginning. Exchange them for twice 100 volts. And I have really nice niche con caps here prepared for the occasion. Yeah, I think I need to clean my desoldering gun. It's a very good tool, but sometimes needs a little bit of attention. Let's check on this side. This big guy. Wait. This really doesn't look nice. And this one. This also looks pretty bad. It exploded inside. You know, tough life basically. This, you know, if you imagine you power it up to today's voltage in Europe, I have in my mains like 240, 235. Be very stressed. Oh no, it's 100 volts. That's a nice thing to see. And this is 50, so most probably this guy caused all the trouble. I will measure them, I will show you the measurements. This tool is very simple. Oh, see? It even doesn't recognize it. So this one is really damaged. Let's see this one. This one is rated 100 volts. It should survive. And it did. Having those caps removed, I will just use my brush and clean here a little bit. It looks better now, but I also forgot that there is a glue residue here that I have to remove. I just noticed this resistor is like covered in this glue. I suppose I have to remove this one, otherwise I cannot get under this one. Yeah, unfortunately. Adds a little bit of work, but what you can do if you want to do a nice job. So this is this one. Yeah, and it's stuck there because of the glue. So let's take it out. And here it is. I think not much color code left on it. Now I have the access to clean all the glue that was underneath. The glue can become conductive, that's why it's important to remove it. So according to the schematic, this one should be 390 ohms, and spot on. Okay, so the board is cleaned in this place. Now it's time to put back the resistor. Almost. Okay. And just keeping my finger here so it doesn't fall off. I will go to this side and just bend the legs a little bit. Just a little bit, so it doesn't move. Okay, now I can place the caps. This version has a very nice thing, at least for me, because each cap, orientation of caps is the same. So I just don't have to worry. I know where is it plus, where is minus. This is one, and the second one. And hope this will resolve the issue. And if it resolves the issue, I will just replace all the caps. I really like to know. So let's order the new caps. And the resistor. Done. And now let's check if this... almost forgot one quite important thing. Yeah, and now we are ready to check if this solved the issue or not. First, let's put back the bridge here. One, and the second one. Here you can see the new caps in place. And I'm ready to power it on, and worked. As you can see, the LED is red. So the cap replacement solved the issue. This was this little guy. Very bad cap, damaged. I will disconnect this cord, and after that I will be able to move it around very freely. So easy without the power cord. Okay, I will start the recap. Main filtering caps are already desoldered. Let's see what's underneath. See what is happening here. See, so the old glue that really can become conductive it's basically connected here, and here you can see the cap start leaking. Yeah, also, if anyone wants to buy the original cap from NAD, I will list it in eBay, but be prepared, the price will be like 500 euro at least for each one of them. Okay, joking aside, this I have to deal with this, unfortunately. This is a mess. It's like everywhere. Okay, let me clean this. Just a little bit of the cleaning process. This will soften the flux and the glue, the old glue, and then easier to... Anyway, this is part of the job. I will put just a little bit of this. Okay. In like 5 minutes it should come off. It's like a basic nail polish removal thing. So after the cleaning, I always check the components around those caps to see if the glue didn't short anything, and I notice here those wires were shorted. I don't think this makes any difference because I think this is the ground, but anyway, it's better not to have anything shorted by the old glue. So I'm ready to install the main filtering caps. Okay. We'll straighten the legs a little bit. This is a nice thing. I usually work with tube amps and they're very heavy. It would be impossible to... The work is of course much different than servicing something like this. Much more stressful working with tube amps. But anyways, it would be really hard for me to keep it in one hand and then install anything. I'm not bending the legs too much, just a little bit so they stay in place. I don't like to bend the legs too much because I always think about the next person who will service. So what I will do, solder just one leg, then using my second hand I will ensure that the caps is really tight to the board. Just a little bit is enough. And just enough solder to keep them from moving. I don't need to stress the caps too much. This is enough. Yeah. This is enough to hold the cap, so I will start with this one. And this one is really tight with the board, and start with this one. Oh, this one wasn't, but now it is. This one. And now it is. And the last one. Nice. And look how they look here. very nicely. Just to show you the process, those are already in place, but they are not yet soldered. To solder those two, I will check the capacitance, which is 10 microfarads, 25 volts. I prepared exactly the same replacement, but rated for 50 volts, which is basically better. And I will now desolder them, and I have to look for the soldering points. I believe this is it. So yeah. And I will be able to remove this one. Yeah, the leg's still hot. Okay, so now when I have them removed, I will just remove some dust from here, otherwise it's impossible. I will not use anything like isopropyl alcohol or anything like this. Just to remove the dust, it's enough. Yeah, and then I will put new caps. And when I don't hold the camera in one hand, I will just bend the legs here a little bit, and that's it. When I solder the caps, I straighten the legs one by one, so then it's much easier to remove it by the next person if necessary. Hopefully it will not be necessary in the next 20 years, let's hope so. As you can see, all the caps are already replaced. Here I use film caps just because I don't have electrolytics. Those are quite small value, 680 nanofarads. And also here I use 1 microfarad 63 volts film cap. And as you can see, the way that I solder the capacitors on the other way, it makes the caps not really straight, but more for me more important is that the next person who will desolder them will not have a problem. The second version of NAD 3020, the main board is a little bit more fragile. All the soldering points are a little bit more fragile than the first version, so this is I think the way, the better way. If the cap is bigger, for example, those 1000 microfarads, then I make sure they are straight or like those. But the small, to be honest, it looks more original than because the original caps were also soldered like this. Yeah, but it's not all the work. Now I will replace. I even don't want to try to remove the original seal paint from this potentiometers to set the DC offset. I will just remove them and replace them. From my experience, it's extremely difficult to set the offset using those spots. I will install a multi-turn potentiometers for this. It will be much easier to set the DC offset more precisely. And then I will, after that, I will decide if I check if everything works or not. Of course, I have to install a power cord. I will not do the same thing as someone before. Of course, I have the proper power cord. This switch is fine, I checked it, cord, and then I will have to replace the thermal pass under all those transistors here, so the heat transfer will be better. Now it's basically dry, doesn't leave anything on my finger. And then clean a little bit the back. Here I vacuum the dust, but it also needs some places to clean. And then check the bias, set the DC offset, and that will be it. So far so good. I already replaced those potentiometers. And check on the other side. Those connections, those original connections usually are quite strong, but it's better to check on the other side if everything is okay, and here it is. So yeah, I will move forward. With all the capacitors replaced, DC offset potentiometers, new one, multi-turn ones installed, now it's the time that I will remove the power transistors and those two, and just apply a fresh solder thermal paste underneath. And I will also change, as I will be there, I will change the Mica pads underneath, and this is the part that I really don't fancy, because the thermal paste, it's like very sticky and it's a little bit blah. I will do it one by one so that I will not make any mistakes. Let's take them out one by one. Here they are on the other side. I can see two screws have solder on them, so I will just first remove this and then unscrew. And here. And I will start with this one. Of course, I need to hold the nut on the other side. Yeah. So here I will hold this screw and then unscrew this from this side. And now it should work better than before. It takes a bit of time and precision as well. Ta-da! It's free. First of 8. And let's try. Wait. Is it so short, or did it fall out of the place like my camera? Fortunately, it fell a little bit, so I don't have to be stressed about the legs. Okay. I should really be wearing some. Yeah, that's how it looks. It's not very sticky, but it still is. I don't know if someone replaced it or not. Anyway, I will wear some gloves and then clean it. I will just apply some isopropyl alcohol here and then clean this a little bit. Not quite yet there. Let's try more. That works better. Okay, a little bit here. Okay. This little fella, it's next. So it's important not to forget about those plastic little washers inside. It's important that the case doesn't touch the metal. Just a little bit of the cleaning process. The problem with removing the old thermal paste and applying new one is that the thermal paste it's like sticky and basically it's everywhere and it's difficult to get rid of. That's why I'm wearing gloves. They help a little bit but not 100%. And fresh thermal paste. I just use a cotton pad to apply the thermal paste to the power transistors. You don't need much of it, just a little bit's enough. I'm trying to spread the thermal paste as evenly as possible, applying a thin layer over the entire surface of the transistor. It doesn't have to be absolutely perfect, because once the transistor is mounted and tightened down, the pressure will spread the paste further and squeeze out any excess, but I prefer to be precise and make sure the whole surface is evenly covered. And installing a new Mica insulator and the thermal paste on it. And again trying to spread the thermal paste as evenly as possible. A thin layer. So this one is already done. 1, 2, 3, 4, 5 pieces to go. One is already done. As I am going to with the replacing of the thermal paste, I noticed that one plastic washer is originally missing here. This is something should not have place, so I decided I will just make this plastic part from this silicone. So this is the original one and this is one I just made. Should do the work. This is the part I made. Why is it so important? If this screw touches this panel, we will, through this screw which is mounted on to the chassis, we will immediately have 30 volts on the output, and this will basically in a second destroy the speakers. This is why is it so important, so that the case doesn't touch heating panel. Yeah, even after I will finish with replacing the paste, I will check if there is no continuity to this. In the meantime, I took some time to clean the back. Yeah, and this thermal passed everywhere. Anyway, I took the time to clean the back panel and it's pretty nice condition. Here it's like a tape. I will just remove it shortly. And now I have to deal with this. First, let's cut the wires here, here, and here. I will also cut this thing here. Okay, it's free to go. Remove this. I just use a pair of strong pliers. I don't think I will be able to do it with one hand, just to show you. I will squeeze it and then just it will let go. Of course, taking care of not scratching the panel. We'll just use this movement and it's done. The same method, but I will use like more gentle pliers to install this. And it's in place, holding very strong. Now I will try to remove this remaining piece of ground wire. Was trying to be gentle, but there is no point. Okay. There's a tiny hole here. I will just remove a little bit more. Okay, that should be enough. So while I'm preparing the wires, just something to notice, it's good to leave the ground wire just a little bit longer, so in case the cable is like torn or pulled strongly, the live and neutral wires will break first and this will stay. The wires are already soldered and the power cable is secured with a cable tie. I will just remove the flux because I added a little bit to solder the wires properly. I needed to be quite generous with the flux. So I'm just about to start it, power it up after all the work I done. Of course, here's the safety thing. And you didn't notice, but it light up slightly. And let's check the main. This is very healthy. Nice. Very good. Very good. Good. And here, I believe. Let's check the DC offset. That's actually, for now, it doesn't need much of a regulation. Of course, it has to warm up a little bit. And this one is also very good. So I think after warming up and adjusting, it will be perfect. But now let's take care of the bias. I have to check it if it's all right. Then the DC offset. Then we'll look at the oscilloscope and maybe clean the potentiometers, and that will be it. To measure the bias, I have to measure across this resistor, but it's shorted, so I will just remove the solder joint from here. This one is also shorted. And then I will follow the original original instruction how to do it. Now I'm measuring the bias, and originally I have 55 millivolts on the right channel, and on the left channel I have around 40, which is according to the service manual, it's fine. It should be between 30 and 60. One thing to keep in mind is I am running this amplifier through a variac to exactly 220 volts. and I will check it out if it's alright if I crank it up to 230, because this is basically the voltage that are here in Europe used. Okay, so I am at 230 volts. I'm still within range. I added, now it's 235 volts, still within range, and that's it. I'm coming back to 220. So yeah, I will leave it like it is. It's a factory chose those resistors. I'm sure they are original and the readings are good. So I will check out the voltages. I will check up the voltages across. So main filtering, it's fine. Also good and good. See, even though I run it through a variac, this one is 36 volts, so the original rating is 35. I of course added a 63, and those original are 35, and I added 50, so now there is some safety space. Let's check the ripple, if it's better or not. It's around the same as it was. Yeah, it's the same. Here it will be for sure better. It's better. It was 400 and now it's 335. Here also I'm sure it will be better. And it is a little bit. I run this through a variac to 200, exactly 220 volts. Now I will crank it out to 230. So now it's around 230, 231, and let's check out this voltage. It's already 31, and this one 37. Remember those caps here, minus 63, and here it will be plus 21. So this very often is rated for 63 volts and it's already like above 80, so yeah. And this is rated usually for 50 and it's minus 63. Okay, now that everything's complete, after some warm-up, I will set up the DC offset. It's very close, but let's get even closer. Not that, yeah. This is a very nice thing with the multi-turn pot. You can get it really precisely. Now that's just perfect. Let's move to the other channel, and that's really close already. Now that's perfect. Alright, the service done. Just a little bit of cosmetical thing. I told you that this likes to move. It's very easy to fix. So yeah, as I told, very easy and fixed. Nice. And I will of course secure it like it was. I forgot about this place. I will just clean this from all of the old flux. Because I want to secure it with some lacquer. So I will just add some coating. That's really it. And now it's time to put everything back together. And also remembering those two screws are shorter. And a little bit of cleaning. Now I'm securing the DC offset adjustment potentiometers with a small amount of locking lacquer. It's time to mount the front panel. Starting to look better. Now I have to install the 4 screws that secure the front panel. I have to be careful not to over tighten them because the front panel is plastic. They need to be tight enough to hold it securely, but not too tight. And the last one. And now securing the screws with locking lacquer, like it originally was. A little bit too much. And corrected. The cover has a small dent that can be easily fixed to make it much less noticeable. And my weapon of choice. Of course, it's not perfect, but looks really much better. Now the signal test on the oscilloscope volume is quite nice, channels are balanced, and now the balance potentiometer. It needs a little bit of cleaning, so the next test will be already after cleaning. It's not very bad, but now you can see just a little bit of distortion. Here a scratchy base potentiometer. And here already after cleaning. The balance is now working perfectly. And here the base after cleaning. Perfect. Now the square wave, of course, treble, also no problems, and the bass, of course, works as it should. Thank you very much for watching. I hope you found this video useful and interesting, especially if you are interested in audio repair. As usual, in the next video on my channel, you'll be able to hear how this NAD 3020 sounds. I'll be using exactly the same microphones and settings as in my other videos, so you'll be able to compare the sound. If you are interested, you can also check out my video about the first version of the NAD 3020. You can see the servicing process and how it sounds on the next video. You can find the link in the top corner of the screen as well as in the video description. And if you enjoy this kind of content, please consider subscribing to the channel. There will be more vintage audio repairs and sound tests coming. Thanks again for watching and see you in the next video.